Let's begin our class now. In today's class, first of all, we will talk about potential divider. So let me explain to you what is potential divider. First of all, as you can see with the name of this one, potential divider. Mean with the help of this circuit, you can divide potential of power supply, or you can simply say potential of cell. So how it divides the potential? So let's try to understand. Imagine that we have one cell. So this is one cell and we connect two resistors. Imagine that we have resistor 1, resistance of this one you can also imagine resistance is R1, and we connect another resistor that is connected in series with a first resistor, and these two resistors, they are connected with power supply. So they are connected across this power supply. We can assume the resistance of this one is R2, and imagine that the terminal potential difference, or simply you can say EMF, because this cell has no internal resistance. So we can imagine its terminal potential difference is equal to V naught. Now for this question, we need to calculate what is value of voltage, means the potential difference across resistor 1. So let's say this is R1, means what is reading on this voltmeter, and we also need to find out what is reading on second voltmeter. Let's say we connect another voltmeter that is across the second resistor. So we can imagine this is another voltmeter that is connected across second resistor. Now the question is that we need to find out what is value of V1. So this is, we need to find out V1, and we also need to find out V2. So this circuit is a potential divider circuit, because in this case you will say V naught, it has been divided into two parts, V1 plus V2. So we have divided this one into two parts. We call this circuit is a potential divider circuit. So this is potential divider circuit. Now first of all, let's try to find out what is V1. To find V1, we need to find out value of current. So if I have value of current, I can find out value of V1 because I have resistance of this resistor. So simply I will say V1 in this case will be equal to I times R1. Now the question is that how we can find value of I. To find value of I, we need to use Ohm's law. According to Ohm's law, V is equal to I times R. So we need to find V1, so we will be using R1. So from here we can find out value of current, means we can find I, and this is the I total in the circuit, I total. So we will take terminal potential difference across battery terminal potential difference, and we will divide this one by total resistance of the circuit. We are calculating I total. Now in this case you can see V naught, so this is value is V naught, and total resistance of this circuit is equal to the sum of R1 and R2. So this is value of I, so simply we can say I. So I is the current in the circuit, so at this point current is I, and this is the current coming from the battery, and this is also the current entering the battery. Current entering and leaving the battery always is the same. So we have value of I total. So if you want to write down I total, so this is I total. Now in this case, as these two resistors, they are connected in series, it means current is the same. So current is the same. So to calculate V1, so we will say V1, this is equal to I times R1, and this is value of I. So this is I total. So we can say V1 in this case will be equal to V naught divided by R1 plus R2, and this is multiplied with resistance of resistor 1. We can further simplify this one. We can say R1 over R1 plus R2, and this is multiplied with terminal potential difference of power supply. So this is how you can find out value of V1. So this is how we can find out V1. Now let's try to find out what is value of V2. In order to find V2, so we need value of I. So we will say this is I times the resistance of second resistor. I we have already, so current is the same because they are connected in series. So let me write down here, as they are connected in series, so current is the same. So we can replace I with V naught over R1 plus R2, and this is multiplied with R2. This is R. Now if we simplify this one, we can also say this is R2 divided by R1 plus R2 multiplied by V naught. So you see here. Now, one thing you need to notice in this case is if you look at this formula for V1 and the formula for V2, you will see a lot of things are similar. So if you look at denominator, this one is the same. So this denominator, they are the same. This V naught and V naught here is the same. So what is different? Only this resistance is different. So we can derive a general formula. Now let's say we have another circuit. For this circuit, let's say we have more than two resistors connected in series. So we have one small resistor. Let's say this is R1, and here let's say we have resistor. This is R2, and here we have this is R3. So we have three resistors connected in series now. So simply you can connect like this. So I will say this is R1, this one is R2, and this one is R3. Now in this case, my question for you is that what is reading on this voltmeter? Let's say this voltmeter is V3. What is reading on this one? If you need to find out reading on this one, simply what you will do is you will say V3, this is equal to resistance of this resistor divided by the total resistance of all these resistors. So we will say that is R1 plus R2 plus R3, and you will multiply this one with terminal potential difference of power supply. This is V naught. So we will multiply with V naught. So this is how you can find out value of V3 in this case. Now from here, we can write down a general formula. It doesn't matter how many resistors are connected in series. If you need to find a potential difference across any resistor, you can simply use this formula. We can say Vn, this one will be equal to Rn, that resistor, divided by R total of the circuit. And this one you will multiply with terminal potential difference of power supply, and you can calculate value of terminal potential difference. Means you can calculate value of potential difference across any resistor. So this one is the general formula you can use for potential divider. So this one is general formula. So very nice one. You will need this one for IGCSE level, and also you will need this one for AS Physics, even for A2, and also you go to university, you will need this one. So this is how what is potential divider, and these are the main concepts about potential divider. Let's move on to next one. You can take screenshot of this and you can save this one, and then we go to next. I will explain you what is thermistor, what is LDR, and then we will do questions. I hope this one is clear to you. Very nice, beautiful thing. Look at this now. You see, now in this case, you see there is no light. So let me highlight some points, then I will explain. So you see in this case, there is no light. As there is no light, it means resistance of this one is too high. There is no current. No light, no current. So this one is over LDR. So there is no current. In this case, you see this is hair dryer. So we can say it's very cold. So this one is very cold. So it means no current. No temperature, no current. Means resistance is very high. Now if I switch on this one and I switch on this one, you will see current will flow. Let me switch on. You can see in this case, light is coming, current flow. If temperature is high, current flow. When the temperature is low, no current flow. Means when temperature is low, resistance is very high. When no light, resistance is very high. So these points you need to understand. Now I will explain you with the help of graph. This one is LDR. This is light dependent resistor. Resistance of this one depends on light. So we can simply write down resistance depends on light. LDR. Resistance depends on light. Light level. The better way to say this one depends on light level. And if you look at this one is thermistor. This one is thermistor. So let me show you this one. First of all, explain you a little bit with the help of this animation. You can see now when there is high temperature, there is current. When no temperature, there is no current. When there is light, there is current. When no light, there is no current. So simply in this case, we can say if no light, no light. It means no current. If no current, it means the resistance of this one is very high. So we will say resistance is very high. In this case, you can see temperature. When no temperature, I will say no temperature, means very cold. No temperature. So simply you can say when it is cold, resistance is very high. When it is cold. Now let's try to understand LDR first of all in detail. So we can sketch a curve. We can sketch a graph between resistance and light level. So you can see resistance is on y-axis. This will be very high, so we will be using kilo ohms. And here we have light level. So this one is light level. And light level is increasing this way and resistance is increasing up. If we sketch the graph between these two quantities, we will see the shape of the graph will be like this. And this shape is telling us if you take a point, let's say we take one point at here and we can take another point at this point. Now if we compare these two, you will see at this point we can compare the resistance and light level. You can compare and second point as well. Now if we look at these 2 points, you can simply see that in this case light level is low. Light level low means that it's dark. When it is dark means night time. Resistance of this one is very high. So this is one thing you can understand. If you look at second point, light level is high. It means when it is bright daytime, resistance of this one is low. So these 2 points you can understand from this. So we can use actually this LDR as a light sensor. So we can sense the changes in the light level. This LDR can be used as a light sensor. It can sense the changes in the light level. When light change, level change, is resistance change. So we can use this one as a light sensor. Now let's try to understand thermistor. Thermistor, simply this one is thermal resistor. So this one is thermal resistor. Thermal resistor means that resistance of this component, electrical component, it depends on temperature. Resistance depends on temperature. So we will say resistance depends on temperature. So this is one main point you need to understand. Now if we sketch a curve actually between resistance and temperature, you will see the resistance is decreasing with temperature. So resistance of this one is also quite high, so we will be using kilo ohms on y-axis and we will use temperature in degrees Celsius on x-axis. In this case, if you sketch the curve, the shape of the curve you will see is like this. So let me draw in a proper way so you can see the clear picture of this one, little bit better one. So it will be somewhat like this. So we can also choose 2 points on this curve. Let's say we choose point A here, so you can say this is point A, and we can choose point B here. Now we can compare these 2 points. If I look at point A, you can see the resistance and you can also see the temperature. Same thing we can do for point B. So this is for point B and you can see the resistance and you can see the temperature. Now if we look at point A, this point, you can see temperature is low. So it means this one is cold. When it is cold, resistance of this one is very high. At this point, you can see temperature is high. It means thermistor is hot, its temperature is very high, so the resistance of this one is low. So these points you need to understand. Now you see, as the resistance of this component changes with temperature, so it simply means that we can use this one as a temperature sensor because this can sense changes in temperature. So we can use this one as temperature sensor. So this can be used as temperature sensor. So these points you need to understand about thermistor and you need to understand about LDR. I hope you have some better understanding of potential divider and you have some better understanding of thermistor and LDR. Let's move on to next one. Now we will use these concepts and we will try to answer some past paper questions. You can also see this animation one time more. You can look at this animation. You can see how resistance is changing with temperature and light level. So this will give you some feelings about physics. Okay, I hope this is clear to you. You can take screenshot of this one and we can go to next. Let's start working on question 1. We will discuss some very nice questions, so please try to do every question by yourself. So don't just sit and study in class like watching movie. Class and watching movie are different. Please start working on this question. First of all, try to answer by yourself. After 2 minutes, I will explain. For this question, it is given to you. Thermistor becomes warmer, means temperature of the thermistor increases. What happens to its resistance and what happens to reading on the voltmeter? So we can take 2 points. So So this is one point as we have discussed before. So let me highlight these points again so you can get some feelings about that. So we can take the second point. Let's say this point is B point. So we can take the B point. So this is, you can say, is a point A. So this is point A you can take, and this is point B. You can see as temperature increase, resistance is decreasing. So resistance B is lower than resistance at A. So this is one thing you need to understand. So we will say when this become warmer, resistance decreases. Now this is thermistor. This symbol you need to understand. This symbol is for thermistor. So in exam, sometimes they will only ask you the symbol for thermistor. So this is symbol for thermistor. Now, if resistance of this one decrease, how about current in the circuit? Current in the circuit will increase. If current in the circuit increase, and if I connect voltmeter here, let's say this is voltmeter 2, I can connect here. So how about the reading on this one? You will say V2, this one is equal to I times R. Reading means the resistance of this resistor. So if resistance of this one is the same but current increased, it means this reading will increase. As this reading increase, and let's say terminal potential difference of power supply is equal to V naught. So we can say V naught is equal to, let's say this is V1. So that will be equal to V1 plus V2. But in this case, V2 increases, but this value is constant. Power supply EMF is not changing. So this reading has to go down. So in this case, you have 2 points we have discussed. One, resistance go down. Voltmeter reading, second point, voltmeter reading means reading this reading goes down. So it means resistance decrease, voltmeter reading goes down. So the answer for this question is A. Okay, so this is how you need to answer these problems. So the answer for this one is A. For example, if you want to use voltmeter formula V1, you will say, let's say this resistance is R1, you can say this resistance is R2. You can also check with that one. So you will take R1, this is divided by R1 plus R2, and this is multiplied by V naught, and we can use V2. For V2 we can find out, use the formula. This will be equal to R2 divided by R1 plus R2, and this is multiplied by V naught. Now in this case you can see R1 is decreasing, this reading is decreasing, this reading is constant, is not changing, this reading is not changing, this reading is not changing. How about this one? I hope you will say this one will increase. So this increase, this one has to decrease. So the answer for this question is A. This formula is very useful. You need to understand how to use. Let's move on to next one. So the answer for this question is A. First of all, try to answer by yourself. You have 2 minutes. You can try. Then I will explain. Let me highlight some key informations. Light falling on the light dependent resistor increases. So if light falling on LDR increase, how about the resistance? I hope you will say decrease, but if you're still not very clear about this one, you can look at this curve. You can look at the graph between resistance and light level. So this is in kilo ohms. You can say the intensity of light. So you can also say intensity of light. So this one is intensity of light. So we can use the unit for this one, watt per square meter. You will see this resistance decreases at light level increases. So you can take 2 points on this one. I just wanna make sure you have picture of this graph in your mind. That's the reason I'm sketching again. Otherwise I can just simply say resistance will decrease. So I want you to keep this picture in your mind, this graph in your mind. So I can take another point here. Let's say we take second point. So you can see in this case, when it is dark at this point, intensity is low, dark, resistance is high. And when it is bright, light level is higher, bright daytime, resistance is low. So it means resistance will decrease. So as brightness increase, light level increase. So we can write down here again, as light level increases, so the resistance decreases. So they are inversely proportional. Okay, now if we go to our question, we can try to answer now. So resistance of this one, this is LDR. So first thing you need to understand, this component is LDR. Resistance of this LDR is decreasing. If resistance of this LDR LDR decrease, so current in the circuit will increase. So I will be writing here current, total current in the circuit, this one will increase. As total current in the circuit increase, for this voltmeter, we can say this one is V2, and if you connect your voltmeter here, let's say this is V1, this is V1, so this is V2, and V2 will be equal to I times R2. Now from here you can see, as current in the circuit increase, it means this reading will increase and this resistance decreases. So these 2 points simply you need to understand. So resistance decreases and voltmeter reading increases, so this reading increase, and this is what you need to write down in your answer. The resistance decrease, voltmeter reading increase. So the answer for this one has to be D. So this is how you can answer this problem. You can also compare this one with V2. For example, this one will be equal to R2 over R1 plus R2. You can also understand with the help of this formula. Sometimes students are a little bit confused with this one. Oh, current increase, resistance of this one decrease, so they get confused with this part sometimes, but you can understand with this one as well. You can see here, as this R1 decreases, this one is the same, this one is the same, this is same, it means this one has to increase. You can understand with resistance if you're not clear with current. Look at this question now and try to answer. This is a different question. We have changed the position of voltmeter. Concepts are very important for your electricity. You need to master them, and most of the students, they have confusion with these kind of concepts. They're not clear. So it's a very good chance for you to improve your understanding. Let me explain to you why answer is A. We have discussed similar type of question before, which simply change the position of voltmeter. So LDR brightness increases. So from here you will say as, so the resistance of LDR will decrease because brightness we will say the light level, or simply you can say the brightness increases. So this is one thing. So as resistance of this one decreases, resistance of this decreases, so current in the circuit, total current in the circuit, that one will increase. As total current in the circuit increase, I can connect voltmeter here. Let's say this voltmeter is V2, and I can say this is V1. Now V2, you will say this is current in the circuit times the resistance of R2. We can say the resistance of this one is R2, resistance of this one is R1. So this is up to us, we can simply assume. Now in this case you can see, as current increase, this value increase, this one is constant, it means this one will increase. So as this increase, then you can go back to this one. You can say V0, let's say terminal potential difference of power supply is V0. So V0 has to be equal to V1 plus V2. As V2 in this case increases, as this one increase, this one has to decrease because terminal potential difference of power supply is constant, it's same. So you will say this one decrease, and question is asking you these 2 points. Resistance of LDR, this is 1 point, and reading on voltmeter means V1. So you can see V1 decrease, resistance decrease. So the answer for this question is A. I hope this one is clear. I have explained you in detail. I hope this is clear to you. Let's move on to next one. Beautiful question, very nice question on potential divider. Beautiful question. Do this one by yourself. Very nice question. First of all, try by yourself. Let me explain to you. If you have done wonderful, if you're still struggling with this one, now you can listen my explanation and you can improve yourself. Answer for this question has to be C. So let me explain you why answer is C. So we will start working on this one. This voltmeter, first of all, imagine that this side is connected with this point. It's connected here. So let me draw in a proper way to give you better understanding. I can simply say this side is connected at this end. And now we can also imagine that when this one is connected across this point, for example, connected across this. Now the first thing I hope you will say that when it is connected at this point, let's say the terminal potential difference of this power supply is V0, means if you connect your voltmeter across terminals of this power supply, let's say the reading on this one is V0. So here reading also will be equal to V0 because it is connected between this point and it is connected between this point, and these points are the same. So it means reading will be V0. Now the second thing you need to understand, what is reading on this one now? This reading will be, let's say this reading is V1. So you will say V0, V1, this one is less than V0. So what does it mean? It means that when you move this slider from P to Q, voltmeter reading is decreasing. Voltmeter voltmeter reading is decreasing. So this is 1 point, voltmeter reading will decrease. So this is 1 point is decreasing. And how about potential difference across this one? Potential difference across the light bulb, if I write down for that, so V naught will be equal to, if I connect voltmeter here, let's say V1 voltmeter, this one is V1, let's say this one is VB, so this is VB. So the V naught has to be equal to V1 plus VB, and these two are constant. This one is constant, this is also constant, so because total is constant, so it means no effect when you move this one here, so there is no effect. So this one is right answer. Brightness of the bulb will not change because the potential difference across the bulb, it will stay same, because potential difference of this one is constant and this one is also constant. Okay, so it means no change, so brightness of this one will remain same. I hope this one is clear.